Welcome to the Cloud Native and Open Source Summit, China 2020. Today's session is about policy management in Kubernetes and how it's moving towards a centralized management model. My name is Olive Power and I'm joined by my colleague Rachel Leekin. We both work at VMware. We're going to talk a little bit about myself just really quick. My name is Olive Power. As I said, I work with Kubernetes at VMware. I'm based out of Singapore. I've previously worked with Heptio and Red Hat, so I have a bit of experience with Kubernetes and about policy management therein. Over to you, Rachel.
Hi, I'm Rachel Leekin. I'm a Kubernetes field engineer here at VMware as well. And I previously was at IBM as a cloud architect. So I have a couple of years of experience in cloud native development applications. So I'll pass it over back to Olive to take us through the agenda and the rest of our session.
Thanks, Rachel. So today we're going to quickly cover, why do we need policy management in Kubernetes? And then we're going to talk about how we sort of implement policy management within Kubernetes. And we're going to specifically today focus on Open Policy Agent, which has quickly become one of the most adopted strategies for implementing security policies within Kubernetes. And then Rachel's going to cover how we centralize this with OPA, how it works. And then we'll hopefully leave time for some Q&A at the end. So diving straight in, why do we need policy management in Kubernetes? So for any platform you're running, and Kubernetes, remember, is a platform for building platforms, whatever platform you're running, security is always a concern, both from the infrastructure side and from the application side. And in Kubernetes, everything is processed through the API. So we have an option to start implementing security at the API level. Kubernetes already has a basic implementation of that, where it uses admission controllers to help you define and customize what is allowed on your cluster. So let's just have a look at that in a little bit more detail. And this is the flow of an API request in Kubernetes. So the request comes in and the authorization is checked to whether that request is allowed either to be processed. And then there's the first gatekeeper, if you like, to deciding in Kubernetes whether that request is valid, is putting it through a mutating admission, which means that a controller is watching that request and checking the content of that request or the specification of that request and seeing if there's anything in there that's not allowed. And if there's something in there that's not allowed, you can implement some logic to change that value to what is actually allowed. So something is specified as having a limit, let's say, for example, a capacity limit of 2 gig, and it only should be specified as 1 gig, then that mutating admission controller and logic around it can be implemented to change the spec of that pod, to change it from 2 gig to 1 gig. So that's a mutating admission. So it checks whether it's right and can edit the specification before it can continue on its sort of life cycle. And then after that, the schema is then validated again to make sure that editing of the pod spec or whatever specification is valid. And then it goes through a validating admission to make sure that that specification is still allowed within Kubernetes. Now, the difference here between mutating admission is that it's just a validation. Is this value allowed? So in our previous example before, we've mutated it from 2 to 1 because that's the implementation that we've specified. That validation admission would say that it's 1 gig and allowed, and so it would allow it through to etcd persistence. However, you can implement code at the validating admission stage, and just like we did at the mutating admission stage, we can implement code at the validation to see if everything that we've specified is actually valid. And as I said, Kubernetes has some controllers that are implemented out of the box, but there's a lot of other use cases in and around security that are not implemented as controllers out of the box. And so with Kubernetes, there are no hidden APIs. And so that means that any request via the Kubernetes API could be seen as valid if there isn't a policy around it that says it's not valid. And so that can lead to several sort of bad behaviors. So you can construct specifications in your YAML files that are valid in their format, but may not actually be valid in how you want that action to be perceived within your environment. So what I mean by bad behaviors is things like is the pod requesting too many resources? So you're checking to make sure that all your pods have been configured correctly and have got the right reservations and limits in place to make sure they're conforming to standards. And so that can be validated at the validation admission stage, and making sure that all your pod specs are constructed correctly. There's also use cases like, are the images that your services, that your containers are pulling, are they secure? So you can implement things like a trusted registry that is specific to your environment, and only images from that trusted registry can be used. So if there's a case where a pod specification file has been constructed incorrectly with the wrong registry, Kubernetes itself doesn't know about that, but you can start applying extra logic in your environment to make sure that only specified registries can be implemented. And there's other things like privileges granted to service accounts. Again, to Kubernetes, there's no right and wrong values for this, but you can start implementing your own code to start imposing the correct behavior and the correct permissions to service accounts. Again, very important from security. Also from services, are they created the correct type, whether it's load balancer, are you allowed to create service type of load balancer, for example, or should they all be cluster IP, for example? And again, other things like pod permissions and the correct storage mounts, things that can compromise your security. And again, so by being able to implement custom code, to be able to implement your own specific security requirements, your own specific policies that are not available out of the box. This is available to you through the webhook code implementation. So this is whereby in the flow, the life cycle of an API request, we can hook out to external providers that can read some external policies that you've written, and they can be validated through the API flow within Kubernetes. So this gives the ability to have like a really a lot of external policies that can be written. So it gives you a lot of flexibility to be able to extend Kubernetes to implement the policies that are very specific to your use cases and your security policies. And one of the players in this field is an open source project called Open Policy Agent. And that allows you to start implementing your own custom code and your own custom policies. And it allows you to be able to run and test these policies before you implement them in your Kubernetes cluster. And you can start getting reports on which policies have been allowed and which policies have been denied. And it's a very interesting open source project. And Rachel, I'm going to hand over to you now to discuss a bit more in depth of what exactly Open Policy Agent is and how it can be used to secure your clusters.
Thank you, Olive. So let's go into more detail on what Open Policy Agent is, or as y'all see me referred to as OPA. Some people say OPA. Officially, it's called OPA by their documentation. So most of you, I'm making assumption that you have gone through a lot of the documentation already on OPA's site. But let's give you a little background on OPA once again. It is an open source, general purpose policy agent that unifies, like I said, the public enforcement for the stack. So that's the kind of gist of the definition. It's a declarative language, Rego or Rego. You'll hear some either terminology or pronunciation. And then also in certain cases, but the case that we'll focus on today is OPA will be deployed as a validating mission controller. So that's the case that we'll be going through today. So not just that as well, but what we want to discuss is that, with OPA, and let me actually go back one more slide. With OPA, you're not just trying to block people from doing things, right? Or just stop the bad behaviors. You have to look at it as your whole strategy behind how do you take that approach from blocking bad behavior or preventing bad behavior. It's a tactic and a strategy that you have to deploy. So one of our colleagues, Duffy Cooley, always says, what problem are you trying to solve? And that's the way that when I and Olive are working with customers, we always take that approach of what problem are we trying to solve with the customer. And as Olive said, a lot of the times they come to us and they say, hey, we have these people who are doing bad things or have bad behaviors on the team. How do we stop them from doing that? And we always kind of look at them and say, okay, well, let's not just stop them, right? Let's look at the whole approach in totality. So in a case like this, these are some examples that I've seen in the real world, right? Real case in customer sites when we get there, is we'll have platform operators will say, I want a developer to require approval before they try to create a service type load balancer, right? And this could be for multiple reasons. This could be because they don't have access to a cloud provider, or it just doesn't fit their needs for the application type, or sometimes they just want to make sure they understand what's happening before a developer can just go and create this service type. That's one example. Another example would be having developers only pull from certain approved registry. So if you know that you want them to only pull from your approved GitHub or Docker Hub, you can do that as well. And then the last one of the other examples is just making sure that you have every resource that's created has a label. So this comes up in a case where sometimes you need a label to indicate what business unit this developer is deploying applications for maybe cost back or charge back, things like that. So you start off by just using these simple reasons and logics, right? You don't really go straight to code. You just start off, what are you trying to solve? And we took this with the customer and we started making policies, right? So now you say policies, well, what kind of policies? The customer says, hey, I think I can do this with PSPs or network policies. And then the customer says, well, maybe we should use OPA. And they weren't really sure. So we sat down and we said, well, what can we accomplish with PSPs and what can we accomplish with OPA? And then we came to the conclusion that you can use both, right? It's not either or, they complement each other. So there will be times that it might be simpler for your team to just develop policies, PSPs. It might just be a simpler, quicker way. And sometimes you need something that's a little bit more robust that can go into maybe looking at external data or things that PSP, right, can't do. So you would look at both, but they're not mutually exclusive. You can use them both equally, both in your cluster without any conflicts, right? As long as you develop it correctly and you look at it from the bigger picture, right? So like I said, why not both? So now I want to take you to how we took those examples of what problems that we were trying to solve into how we turned those into code. So I'm going to make the assumption that you've gone through some of the documentation, right? With OPA, there's different types of OPA. There's different versions. So there's the kube management version. There's the gatekeeper version. In this example, I'm going to focus more on kube management because it is I want to say it's a little more developed and it's being used a little more by customers right now than gatekeeper because of gatekeeper still somewhat in beta. So it's a little more stable. So these examples are how it's more focused on kube management, which is deployed as a config map, right, in your cluster, versus gatekeeper is deployed as CRDs, and that also changes the way that you write your policies. So it's a little different, which we would probably say for another time, another session, Olive. But for right now, we'll stick with what's the simplest way for you to get started, right? You want to get something that you get started, get the process flowing. So as you're ready to explore Gatekeeper, you already have a solid foundation on how to build your policies. So we'll take that first example of we wanted the developers to require approval before they try to provision a load balancer service type. So as you can see here on the slide, this is a very simple policy. And that's one thing you should keep in mind is that sometimes people, customers, they want to write these very complex policies, and to keep in mind that sometimes the simpler is just better, right? It gets their point across, it does what you wanted to do, and later on it saves you from trying to figure out complications as maybe teams switch in and out and someone else wrote the policy and then the next person comes in and they don't know what this person was, the rationale behind the policy. So sometimes just keeping it simple is the best method for writing these policies. So in this example, OPA has a policy, a package statement, and this is just very generic right now, but you can name it based off of your strategy. So for example, if you have cloud A and team B, you can say this policy belongs to cloud A team, and they're going to just write this portion. And then, for example, if you have another policy that's slightly different, that might be focused on maybe cluster IP, you might have cloud team B might have that policy, so you would change the package to that. It's based off of your strategy, but you want to keep it, as I said, very simple as possible. So then you have operations of where you're trying to create and update a policy. So once again, very simple, the Kubernetes resources, right? You're just, methods, you just want to either create or update. So this is what that applies to. So if they try to destroy a service, it's not going to do anything because it's only looking if they're trying to create or update a service. And then here's the deny. So it's going to deny, and in this parentheses here, it gives you the reason of why, but it's going to deny if it sees a service come through, and if it does one of those operations, and if the spec type of that service is load balancer. So the reason why you see this here, the reason is load balancer, and then you see the next reason is the same reason, but it just says node port. Now the logic behind this when we were creating it was sometimes you might want it to block both, right? But if they have the same error message, they might not understand what they're blocking or what's being blocked. So we took the same policy and just had it customized a little bit. So this way the user interaction with OPA is also positive as well. So they can see what's actually being blocked. So that's a very simple policy. Then now what you would do with this is you got your policy, you want to test it locally. Before you do anything in the cluster, you want to really test it locally because it will just save you a lot of headache later down the line when you know all your policies are working locally. So what you have here on the side here is a test case. So if you're familiar with traditional development where you might see they're developing JUnit testing, right? This is the same kind of feel. You have your use case here and your test case, and it gives you what would be a kind of like a manifest and YAML, right, in JSON here format, and it's testing against to see if this example would break the rule or be allowed in OPA or not allowed in OPA. So you can, it's a lot of details here, but you can see that in this case it should deny because it's a load balancer type. Now for the next slide. It's the same policy on this side, but if the user tries to deploy a cluster IP service, it will allow it. So this is how you build out your test cases. You want to make sure you have coverage for all the possible scenarios, right? The more scenarios you have, the better test coverage you have before you get into your cluster, and it really gives you preventative measures. So now that after we've kind of tested locally, you would see you'll get a pause, you'll make sure all your test case pass. You would to now deploy this same rego policy into your cluster. Like I said, that will be deployed as a config map. Of course, you'll go through all the standard setup that you need to do to get OPA deployed onto your Kubernetes cluster. So I'm making that assumption that all that has been done and your policy has been accepted by Kubernetes. So once all that's done, now you would start testing it in a possible real world scenario. So here's how we would do that. We would have a YAML similar to what we had previously, right? But now it's in YAML format. And it's just going to test this. In this case, I like to always test what OPA will let through first. So in this case, I know that it's a cluster IP example here. So OPA should allow it to go through. And as you can see from the screenshot, that's what it does. It goes through. And then if my next one is what happens now when I want to do load balancer type. And just so you could take a look at it, I've tried to pass that through. and it gives me this nice error message, which was what you saw in the previous slide of what my personalized message was. So with all that being said, I want to take also a step back and give some pointers on what we've experienced with customers when doing this. Is once you create the policies, you want to look at it long term. So when you create one policy, you know other problems are going to come up. So you want your policies to be somewhat open-ended, that you can update them later, that you can add to them later, that you can also modify them. So you want to make sure that your policies are not so rigid that it makes it difficult to update as your circumstances change in the future, or as your Kubernetes clusters mature and your developers mature, right, with Kubernetes. So that's one thing that we've learned. Also testing with the in cluster, right? Something like this where you see, you want to make sure that you're testing a cluster that no one else is using, because if you block something, that we've run into this where, you know, you might be testing with someone else and they might try to run something and it blocks. It actually, OPA does a great job and actually blocks them. So you want to make sure you're testing in a singular cluster. And another tip that we learned through this process is that OPA is always changing. So you want to make sure you're up to date with it. You might also want to consider putting OPA into your CI/CD pipeline. We've seen customers do that, where they have a nice pipeline on how to deploy these policies to their cluster through CI/CD. So things like that make it a lot easier than manually going in and deploying each policy as a config map, right, for example. And then lastly, just thinking about the future of Gatekeeper, you want to make sure whatever policy you create now, that you can convert them to Gatekeeper templates and constraints in the future. So that's something that we've had customers think about. Let's see, last part to this is, oops, hold on one second. There we go. I want to also mention that Strata has a, oh, hold on, I've got to switch to, one second here. There we go. So Strata is the company that has the maintainers of OPA, but they also do have a nice UI that they've been developing over the last couple of months, I've seen, where you can take your centralized policies, right, and get a nice UI to them. And I think this is something that it's worth checking out for your team if your team is looking to have more of a user interface experience versus command line experience. And then one other piece is, how do you get involved? What's the next steps? Just go straight to GitHub, go to the Slack channel, go to the documentation. OPA is a very great community. I've had a blast working with the people on the team, and they're very responsive, and the community is growing, looking to grow, looking for help, looking for new ideas. So I definitely suggest, if you have time, to take a look at all of the community activities and get involved that way. So all that being said, thank you. Had a great time presenting today, and we'll look forward to the Q&A.
Thank you. Bye.
Thank you, everyone.
Okay. Thanks, Oliver and Rachel, for the great talk. Thank you.
Hi, good morning. Well,
no problem. Thanks.
And yeah. Do we have the QA session?
yes.
Oh, okay. Let's go ahead. Let's go ahead and check the QA zone in Zoom.
Yep.
Okay. Yep. There is one question.
How can I set OPA best practices in CI/CD?
Okay, sorry, I didn't see the Q&A session there. So yeah, so one way that I've seen the customer use it as with their Jenkins CI CD platform is that every time a cluster is created, they have OPA A installed right through their CI/CD platform through Helm charts, and they also then deploy the policies automatically. You know, they deploy the config maps, right? The policies as config maps. So that was one way that they chose to do it. Does that answer your question?
I would say so. And then I guess you can, you know, you can edit those policies, right? And then just they can just like blend into your CI/CD pipeline as those policies change, yeah, and grow. Because I guess a lot of strategy is implementing sort of a minimum set of policies first, and then start building on those policies once you kind of get comfortable about where you're going to implement those, whether they're an OPA policy or whether they're, you know, Kubernetes sort of a mission controller type policy.
Okay. Any other questions?
Last session of the conference is a little bit quiet.
Yeah, well, we have another like a broadcast channel. I mean, outside of this Zoom, so lots of people are outside from this Zoom meeting. Yes.
Sure.
Yeah. So yeah, if you have any questions, you can email to our speakers, and then they can answer any of your questions. And thank you, Oliver and Rachel.
No problem. Thanks
For
for having
the
us.
for the
It's a
great
real
talk.
honor. A real
Yeah,
honor
thank
to
you.
be part of this conference. Thank you.
Yeah, thank you. Have a good
Same.
one.
Thank you.